expert on heat pump technology, Jake Marin from Efficiency Vermont. Jake is the manager of Efficiency Vermont's HVAC program, which provides rebates on efficient equipment as well as technical information and assistance to customers, homeowners, and installers. He coordinates all of the heating and refrigeration programs and guides the long-term strategy for the Vermont market. Jake's particularly interested and involved in heat pump technology and has become known as the heat pump guy for all his work in the Northeast. Jake, take it away.
Hello everyone. I'm going to try to untether here a little bit. So I'm going to start off by also reiterating what Bob already said. This is a really, truly impressive crowd. This is the fourth of these workshops we've done, and I don't know if it's just because Bob's such a great organizer or this is just really an incredible community. Probably a little bit of both, but clearly, it's not just the topic. This is really a spectacular turnout here. The one other thing, I have to apologize in advance. I'm leaving my phone turned on. My wife is 38 weeks pregnant. I'm really hoping that I can make it through the presentation tonight. So I promised her I would leave it on. So if it rings, I'm going to stop and look at it. That's it. Okay, so here we go. Let's jump right in. So what we're going to do today, I'm hoping that this talks to all of you in some way at least. We're going to start off with technology. I'm sure some of you are already pretty familiar with the technology. Hopefully the installers in the room are very familiar with the technology. But I want to make sure to get everybody on the same level playing field so we all understand what we're talking about. And then I'm going to talk about some of the economics. What do these things cost? How much money might you save? That sort of thing. And then from there, we'll look a little bit more into what makes a good application, right? These things can work in very diverse situations, but not every situation is perfect. So we're going to talk a little bit about good and maybe not so good applications. And then I'm going to finish off by talking a little bit about some support that's out there to kind of help you. So in addition to these kind of sessions, there's actually some money out there that, with Efficiency Vermont, there's loan programs, there's all sorts of things. So we're going to talk a little bit about that. So, starting off, benefits of heat pumps. So, one of the things that I think really makes heat pumps incredibly unique as a piece of equipment is that they provide heating and cooling out of the same piece of equipment. Kind of hard to imagine how that could possibly be true, but not only do they do that, they do them both of those things very efficiently, very well. And a ductless heat pump, and don't worry if you start to get lost in some of the terminology, we're going to dig in a little bit more about what some of these terms mean. Ductless heat pumps are a really great way, if you've already got a heating system, to retrofit, to an add-on to your existing system in a way that's really quick and very non-invasive. Just a little small hole through the wall, in and out in less than a day. If you're building a new home, is anybody here interested in building or in the process of building a new home? It's a handful of folks. What we're seeing more and more is that people are opting for this equipment because it's actually the least expensive way to go, because you don't have to put in all of the piping and ductworking and all of that you would in a conventional heating and cooling system. And, of course, I imagine, I know there's some solar folks here, when combined with renewables, you can basically have completely renewable heating and cooling, which is really a very unique thing about this technology. So let's dig in. So what is a heat pump? I was talking to a woman earlier tonight who said, I didn't really understand this heat pump thing when I first heard it. It was like, how can a pump heat your house, right? I mean, maybe you can imagine it could pump something in or pump something out, but how is a pump going to heat your house? So the best way I think I started to understand this when I first started learning about it is, have you ever walked over to a window air conditioner and felt the outside of it and felt the heat that's blowing out? I guess I always thought that was, before I learned about heat pumps, I thought that was just, like the electronics inside there, friction or some kind of heat that's generating. But what you're actually feeling is heat being extracted from the inside of your building space and being pumped outside. So you're feeling the heat of the inside of the building being pumped out. And you might think, well, but it's hotter than the inside of the building, and that's the whole point, is that heat pumps collect sort of diverse heat, concentrate it, and then pump it somewhere else. So we're going to talk a little bit more about that. So a couple of terms, and I promise them this is not going to be a super technical talk, but a couple of terms that I do want to start to get you familiar with is this idea of a heat pump moves heat from a heat source to a heat sink. So I'm going to repeat that. Heat pumps move heat from a heat source to a heat sink. So the heat source, in this particular case, is usually something out in the environment, right? So in this particular case, we're talking about an air source heat pump. Has anyone heard that term before? Air source heat pump. So what we're referring to there is that the heat energy that's being used to heat the building is actually being derived or extracted from the outdoor air, okay? So this is just a really basic schematic showing a couple of different parts to a heat pump, and you're extracting heat from the outdoors and you're pumping it inside. And this is what the outdoor unit to one that I've seen some flyers here for an air source heat pump. That's the outdoor component. That's running right now with all that snow out there. So another source is ground. You've probably heard the term geothermal heat pump or ground source heat pump. What that's referring to is that the heat energy is being derived or extracted from the outdoor ground, or as well as also water. Okay, go back real quick. There can be lots of ways ground source heat pumps can work, but a lot of times you're burying pipes, lots and lots of piping in the ground to extract heat energy that's in the ground. I will admit that when I first heard of a geothermal heat pump, I thought we were talking about hot springs or like Iceland, or tapping into underground lava flows or something. We're not talking about that at all. What we're really talking about, the way these work, we're talking about regular old normal kind of 48-degree ground, right? There's a ton of heat energy that's stored there if you can get access to it. So water is probably really the most common version of a ground source heat pump in Vermont. And again, same thing, we're not talking about anything special other than well water, okay? You're tapping into the water, you're extracting heat energy from it, and you're concentrating it and delivering it to your space. So I said that you're moving heat from a heat source to a heat sink, right? I said that a couple times. So on the sink side, what we're really generally talking about here in very layman's terms is your building, okay, for the most part. When we're talking about space heating, we're talking about the building. And so you can deliver heating in different ways, just as you already are in your homes. You're either delivering it through air. In this case, we have an example of a ductless heat pump. There's one running right over there. But of course, you can also deliver into water. So we're not seeing a lot of this in Vermont right now. I know there was some interest. I received some emails in advance of this, some folks that are interested in delivering their space heating with water. And my guess, if I polled this group, is probably at least 75% of you are heating your homes with hot water. So how many people here are heating their homes with, you got baseboard hot water going around? That's at least 50%, maybe not. How many have ductwork and forced hot air? Yeah, so probably about a quarter. So it's usually about a quarter to a third folks use forced air. So you can heat air, you can deliver it that way. You can heat water, and you can deliver it that way. In addition to space heating, right, heating up your building, you can also heat your water for showering and cooking and that sort of thing. And so heat pump technology can be used to do this very, very well. So what we have, what we call heat pump water heaters. These are a version of air to water, right? You're extracting heat energy from the outdoor air and you're delivering it to the water inside the tank. And these are really pretty cool. They use, I imagine most of you came here to hear about space heating heat pumps, but these heat pump water heaters are really an incredible option right now. They'll use a half to a third of the electrical energy of a conventional electric water heater to do the same amount of water heating. So a ton of energy and money saving opportunity there. That's 50 to 66% in your energy cost savings. And right now, Efficiency Vermont is actually offering a $550 discount on the purchase of this equipment. So the units only cost about $1,000. So we're talking about more than half of that we're paying for to help move you forward on that. And you're going to start seeing more and more of these because some new federal standards just passed in April. It's actually requiring all larger water heaters. They have to be heat pump water heaters now. So if you've never heard of this before tonight, you're going to hear about this again. Likely you're going to start seeing these things all over the place. So get in while the getting's good, is what I would tell you. So heat pump water heaters, this is I think my last slide on this. Just a couple of quick things. Number one, they're not good for everybody in every situation. They really should be installed in a basement. Is really better than a living space. They do make some noise. There's a compressor up on the top. So they're not really good to have outside your bedroom or in your living room. If you have a basement that's not staying at 50 degrees when it gets cold, really cold out, you can start having issues because these things are actually, because they're extracting heat from the space they're in, they're actually cooling the basement down a little bit. So they're going to operate most efficiently and when it's warmer, and you really don't want to cool your basement down that much. But I would also say, if your basement's going below 50 degrees, you have other issues. We have some information here about our home performance energy. So you want to look at maybe insulating your basement, those kinds of things. You do need at least a 10 by 10 room, so it's not good for a little tiny closet. And they do produce condensate. There's a cold coil on there that will, water will condense on there and drip. So you need somewhere to be able to put that, whether it's in this one, I think there's a little floor drain, you probably can't see that, but it's either that or you have to pump it somewhere. So just a couple of things to consider. Moving right along, we are really going to focus today on just space heating. I wanted to mention heat pump water heaters because they really are a great option. I think often get overlooked, very accessible. So some equipment terminology. As I said, I'm not going to be too heavy on the technical side, but I do hope that at least, we've got what, probably over 100 people in the room right now. And I hope that from here, what's that?
180.
180?
Yeah.
Wow, okay. Yeah, 180 people in the room. That deserves a little quick round of applause. So I hope that all 180 of you will now go out and stop spreading the misinformation about what these, the terminology that's used on these things. So the first one is, what's a heat pump? Heat pump doesn't necessarily mean space heating or water heating. It's just the overarching technology, right? So when people refer to heat pumps, you might say, well, which kind of heat pump are you talking about? So, but a ductless heat pump, and that's what we're going to spend the most of our time talking about tonight. Sometimes you might hear the term ductless mini split. Those are the same thing for the most part. It's a heat pump in which you're delivering your space heating, right? These are space heating heat pumps, not water heating heat pumps. Air source, air delivered heat pumps, or an air-to-air heat pump, in which you don't have ductwork, right? You're not putting the heat into ducts and then sending it out to the whole house. You just have these things, just like there's one right over there under Arc Mechanical's thing. Those things are mounted on your wall, and that's your source of heating and cooling. It's not feeding into ductwork, right? A mini split, that's another term you'll hear. Sometimes people use the term mini split when they're referring to this equipment, but just generally a mini split is it's a type of heat pump for space heating in which you have a split between the indoor and outdoor components. So there's other versions of mini splits that aren't ductless, but suffice it to say, what makes them unique is that there's an outdoor component, there's an indoor component, and the two are connected, okay? And then, of course, there's the term that we're starting to hear more and more, which is multi-split, or multi-port, or multi-zone. These are all the same thing, which is where you have an outdoor component. There is still a split between indoor and outdoor, but now you have a single outdoor unit with a series of indoor units, okay? So you can actually heat or cool with zones in different rooms. So a lot of folks are starting, there's better and better equipment that's coming into our market now that enables you to not just heat your living room, but now you can get the master bedroom and the hallway upstairs and the, and the living space, all off of a single outdoor unit. So you don't have to have these things sort of scattered around the whole exterior of your home. Okay? So efficiency acronym. So another literacy piece here is that unlike conventional heating equipment, where we're used to saying, what's the efficiency? And you get a single number, and it's, what percent efficient is it? And it's very simple, I think. People can really understand that 100 is really good, and less than that is, lower is worse. But with heat pumps, we have 3 different, and in fact, there is even a 4th I'm going to mention here too. We have this HSPF, SEER, and EER, okay? And so I tried to color code them. HSPF is heating, that's the red one, right? That's the heating seasonal performance factor. It's kind of a seasonal efficiency, and it's expressed in BTUs per watt. How many BTUs of heat energy are you able to deliver with 1 watt-hour of electricity, okay? So SEER is the same thing on the cooling side. That's the seasonal energy efficiency ratio, and the EER is not something that's probably that interesting to you guys. It's really more important for utilities. It has to do with when this thing is cranking on the hottest day of the summer, what's the efficiency? It's important to us in order to manage grid resources and ensure that we're not basically overstretching what the grid is capable of doing. Okay. But are they efficient? Everybody here probably came in tonight assuming these things are efficient, but we're not really sure how or why or what makes them efficient. So the key here is that unlike most heating equipment, really pretty much all heating equipment, you're not burning anything, right? Or the only exception is that in electric resistance, you're using resistance heat, right? For conventional electric heaters, you're trying to cram a lot of electrons to a very small area, and there's friction that's created. Other than that, you pretty much got to burn something if you want to make heat, right? But a heat pump isn't using either of those strategies. A heat pump is just taking heat from one place, right, your heat source, and it's just moving it over to your heat sink. And heat pumps all have this high HSPF, right? This is our seasonal heating efficiency. The higher, the better, okay? Don't worry about what the numbers are right now, but just remember, if you're looking at 2, you're looking for a higher HSPF equals more efficient, right? It's more heat delivered for the same amount of electrical input. So these all have COPs between 2 and 4 across the season. So what is COP? So this COP is a 4th efficiency metric that really helps us compare to other existing heating systems. Because if you're trying to compare if I tell you that a unit has an HSPF value of 13, and you say, is that good compared to my 90% efficient furnace? I can't tell you. I mean, I don't know, right? Those things, it's apples and oranges. So COP is a way to start to kind of try to compare to a conventional heating system. It stands for coefficient of performance, and it's really just a ratio of the energy out, right, that heat energy out we were talking about, to the electrical energy that you put into the system. So a COP of 2 to 4 is actually like saying it's equivalent to a 2 to 400% efficient heating system. The sort of gold standard, so to speak, is electric resistance. That's a pure COP of 1. That is, for every unit of electrical energy you put in, you get 1 unit of heat energy out. Okay, that's the law of it. There's nothing lost, there's nothing gained. People say that electric heat is inefficient. It's not. It's 100% efficient, but it's a very expensive way to produce heat. Right? This is going to do the same job for a half to a quarter of the amount of electrical energy. So how can you get more out than you put in? So I created this little diagram to give an example of what a COP of 3 might look like. So you got your sort of heat pump, okay? Your heat source, we talked about this several times now. You've either got ground, air, or water. does take electricity to run this. You have to put, there's lights, there's a compressor, there's fans, there's all sorts of little widgets and gadgets and gadgets that take electricity to run, okay? It's not magic. So you got to put some electricity into the thing. It does its little magic routine inside the box, and out comes 3 units of heat energy that you're delivering to the house. Now you'll note, I don't want to confuse folks, you've got kilowatt hours, which you all know because you pay an electric bill every month. But you're not probably used to seeing heat energy referred to as kilowatt hours of heat energy. The one thing I'll tell you is that energy can be expressed in all sorts of ways, right? We could, just like converting inches to centimeters, we could talk about BTUs, we could talk about joules, we could talk about calories, talk about kilowatt hours. These are all measures of energy, okay? So the 3 kilowatt hours of heat energy that goes in was really just produced by putting 1 kilowatt hour of electricity into the system. So you're getting 3 out for 1 in. So this is really the core of it. This magic part that I sort of breeze over here is what's called the refrigeration cycle. That's sort of the physics, the science behind it. It's not magic at all. It's really just pure physics that if we were to take the time, I could explain to you, but it would take a little while, and there's other, probably more important things for us to get you tonight. But if you're interested, go home and Google refrigeration cycle, okay? Not great. So how many people here have heard the term cold climate heat pump? Quite a number. Anybody want to try to define what a cold climate heat pump is?
Well, they might work here.
Good point. All right, well, I will do my best to try to define it, because I asked a lot of people and nobody was able to tell me what they meant, other than some of the manufacturers said, it's this thing we sell. So I got together, this isn't just me alone, but there's a group of us who've sort of tried to start to define it. But in essence, I think a cold climate heat pump is a heat pump that maintains capacity. Now the term capacity, that's synonymous with output, okay? Maintains output at very cold temperatures, and it also does not compromise efficiency to a large degree while doing so, okay? So in other words, to paraphrase this, when it gets really cold outside, the thing's still putting out heat, and it's not costing you a ton of money to do it, okay? So that's I think at the highest level, what defines a cold climate heat pump. So is this new? Why are we all hearing about this now? Okay, it's because there have been some significant technological advances over the last several years. There have been these new refrigerants. So the refrigerant is, some people refer to it as coolant or freon. It's the material that's inside the heat pump system. Has some very unique characteristics. They're developing new refrigerants all the time. So some of these new refrigerants are really what's opened the door toward to really, really high efficiency and high output at very low temperatures. Also with new materials technologies, these systems are able to operate at incredibly high pressures. Okay, that would have cost a fortune in materials and copper and all of these things to do before. But with new materials technologies, we're seeing higher and higher pressure systems for still very reasonable prices. Variable speed compressor. The compressor is sort of the engine in the whole machine, and the compressors, conventional compressors and heat pumps, they bang on and they bang off, right? Just like your refrigerator, it comes on full bore and then it shuts off completely. With these systems now, they're modulating, right? They try to kind of come up slowly, find their happy place and hum along, and because of that, it really enables the equipment to be very, very efficient, even at very low temperatures. And of course, the control piece, probably the least sexy part, but really, in some ways, the most important. I would even go so far as to say that most of the equipment out there is really not all that different from a hardware perspective, but what really differentiates one from the next is sort of the brains behind it. And just as, did anybody here own a cell phone in the 90s? Those things used to look like? A couple of you. Right? I mean, if you think about what that looked like, and what could that thing do? Make phone calls, right? From your car only, though, probably, right? But, so now what can your phone do? I mean, you think about the technological advances that have happened in that same thing is happening with heat pumps. So that's really kind of the unsung hero here. You'll hear a lot about all these fancy things, but really it's the brains that's making it all. So the economics. So I'm going to focus in on one very specific piece of technology because I think what we're seeing in the market is that really most people, I bet, here came to hear about this. Ductless mini splits. That's what all the folks that are here that do installs focus their efforts on, and I'm sure will support me in saying that that's really where the biggest market is right now. So we're going to talk a little bit about that. So the first thing I want to mention before I go into this is, if you're thinking, oh, my heating system that I have at my house right now is about to die, and when it dies, I'm going to put in a heat pump, it might not be the best fit for you. And this is why. Because with an air source heat pump, there's a decline in output and efficiency. Even in a cold climate heat pump, there's a decline in output and efficiency as it gets colder outside. And what does your building need as it gets colder and colder outside? It needs more heat, right? It needs more and more as it's providing less and less. And so, don't get me wrong, there is an incredible opportunity here, and I'm going to go into the numbers. But what we're recommending is really you need to maintain at this point, unless you have an incredibly well air-sealed and insulated home. There are some out there that are heating exclusively with heat pumps. You do need to maintain an existing system. You have? Great. So there are folks out there, but it's rare. Your one is
not working that well.
Yeah. Okay. So there we go. So what we're recommending is to maintain your existing heating system, but to displace or offset as much of that expensive heating as you can with your air source heat pump. Okay, so we're calling it this displacement model. 80% is the number, I'm sorry, I didn't get this up for you. So 80% is the number that we're kind of targeting. So the before would be you've got this single central system, probably not realistically for you. You probably a wood stove and a little electric strip heat in the mudroom and maybe a furnace. But overall, you're doing most of your heating with your central system. We're saying shift your central system really into a backup position for when it gets really cold, and do the bulk of your heating when it's a little bit more mild outside. It's going to save you a ton of money. So we'll get into it. So this is a busy slide. Don't get lost in it. I just want you to look at that far right column. What this does is this is a way to compare the relative costs of different fuels. So people always say, how do you compare a quart of wood to a gallon of propane? I mean, it's just hard to compare which one's more expensive, right? In terms of apples to apples. So this gives you a way to compare the relative fuels. And you can see they're organized, and I apologize, I've updated this slide like 100 times. I haven't done it recently, and some of these numbers might be a little bit outdated in terms of, you might look at this and say, $3.22 for fuel oil, we're getting it for $2.75. But these are, I'm telling you, it's very transparent, what are my assumptions, what's the calculation based on, but you can see where heat pumps fit. They're up here in the sort of wood and pellet kind of range. Quite a bit less expensive than, say, fuel oil is here. And fuel oil is at a real low right now, too. Excuse me. Propane, maybe, half the price of propane. So a typical residential heating cost, don't worry about that, 75 MMBTU per year. That's really just a technical way of explaining the type of home I'm talking about. I call this kind of an average home. And you can see that, average heating costs for most folks in the state of Vermont are somewhere between, $2,000 and $3,000 a year. Does that sound kind of on par? This was a cold winter, but you really get some nods on that. So if you were to put in a heat pump and replace 80% of your heating, this is not a full swap over, this is just to do 80%, and you had the fuels at the prices on the previous slide, these are the kind of, or I'm sorry, 2 slides ago, these are the kind of savings you might see each year. So somewhere between $600 and $1,600 a year, depending on what you have for fuel. And again, these are rough numbers because fuel prices, who knows, in 5 years from now, we could be paying $5 a gallon for fuel oil. So it's a tough one to nail down.
Jake, does that include, you accounted for the added electricity?
Yep. This includes the additional electricity costs. Thanks for pointing that out. And I'm going to go into more detail on what that looks like here in a second, just so that you can see I'm not just making things up. So playing with numbers. So if you've got, you're going for 80% displacement in an average home, and you're currently running on an 85% efficient oil system. So what that house would look like is you'd be spending about $2,000 a year buying 640 gallons of oil to heat your home. And once you put your heat pump in, you're still burning some oil because, like I said, you've only displaced or offset 80%. So 20% of what you were burning before, you're still burning. So now you got 128 gallons of fuel oil. And then you've added electricity, right? Because these things, as I said, they're not magic. You do have to put electricity into them. And so what that works out to is now you're spending $400 or so on oil, $1,000 on electricity. You're $1,400, $1,500 a year versus that $2,000. So this is, in this particular example, and this is on the more conservative side, you're looking at probably about a $600 a year savings. And for those of you who are interested in reducing your carbon footprint, that's about 3,600 pounds of carbon dioxide less that you are responsible for emitting into the atmosphere. So, any questions on that one?
Does that take into account the electrical generation plants?
Yes, that is net. That includes transmission losses and what the electrical, this is based on Vermont's blend of electricity.
I'm concerned about the CO2.
Yes. Yep. All of those things are taken into account.
There's just some confusion here. The net savings you've got is a 52% reduction.
Yep.
But you're saving $590 over an original cost of $2060.
Yep, this is, I'm sorry, the 52% reduction this is the energy reduction. So your energy reduction has gone down 52%.
I'm just saying that's kind of misleading the way it's written there. Because I'm focused on dollars. Sorry.
The dollar reduction is about, I'd say, 600 out of this, 30%-ish.
I'm just
1/4,
just
25%.
suggesting.
How realistic is 80%?
80% displacement?
Yeah.
Oh, we're seeing that a lot, yeah.
Good.
You know, you have to put in enough equipment that meets that need. That's not necessarily just, everybody puts in one unit and you're gonna all get that. So sometimes you have to put 2 or 3, depends on the size of your home and efficiency of your home and that kind of thing.
So are you amortizing the installation cost?
Yeah, what about that?
That's not included installation cost. This is just operation cost. Okay, there's no installation. I'm getting into installation now. So installation cost, another really common question we get, how much do these things cost to install? How much does it cost me in my home? And it really, of course, everybody hates the answer, it depends, but it does. But what I will tell you is that a single zone ductless system on average we're seeing about $4,000. That's a big average. There's a lot of different pieces of equipment, a lot of different sizes of equipment. You might go to put one in and it might be $6,000. Don't get me wrong, this is an average. Multi-zone ductless, they can vary from 2 zones up to 8 zones. So those can be $6,000 systems, they could be $20,000 systems. And then of course if you go toward the ground source route, that is an open-ended. It's the cheaper systems I've seen are in the sort of $20,000 range and they just go up from there.
This is labor plus?
These includes labor and material costs. Okay, this is a fully installed cost.
Are they all similar BTU output though?
These are big averages. If I were to try to break this down into a detailed thing, what I recommend in terms of cost is talk to an installer because that's the only way you're going to get something that's meaningful for your individual situation.
I understand that, but when you say ground source 20,000 and single zone 4, are they both putting out the same amount?
No. No, these are a single zone ductless, let's say on average that's about 12,000 BTUs, right? That's about what we see, 12 to 15,000 BTUs. And multi-zone, that's going to range from, that might be 18 or say 24,000 BTUs up to 48,000 BTUs in size for the largest units. Ground source could be anywhere from 36,000 to 60,000 BTUs.
So the cost for the output isn't as variable as single as the units are shown. Because you're getting a lot more for your $20,000 investment in ground source than you are.
Again, that is low end. I mean, I've seen lots of systems in the $70,000 to $100,000 range. So if you're interested in ground source, I can talk to you afterward. I'm not going to spend a lot of time on that today because I think there's not as many folks that want to hear about that.
Cheap market.
Yeah. You got a question in the back?
Yeah, you speak a lot about using them in the heating cycle.
Yep.
What about the counter side and cooling cycle?
Yep.
What is the cost of the cooling cycle? A lot of us have room air conditioners
Yep.
put in our windows.
Yep.
And the benefit of having heat pump will be both. So where does the influx of the crossover between cooling and then the summertime? You got your room air conditioners and you get heat pumps.
Can you repeat the
Great,
question?
the question is really about the cost of around on the cooling side of things. They are incredibly efficient cooling machines. I don't have any analyses right now to really compare. I often get asked the question, what's the cost difference between a window AC and a ductless heat pump? And they're just, it's such an apples to oranges comparison, but I would go so far as to say half to a third the cost to operate, somewhere in that range. Not a hugely compelling financial reason to swap over window units to these just for that alone. There's just not enough cooling in the year to justify it like there is heating. That said, a lot of people, my hotel room that I checked into had a ductless heat pump that was cooling, and it's a beautiful thing. They're very quiet. You don't have to take them in and out of the windows and get the crappy, moldy water all over your shoes. It happens to you, I'm sure it happens. Put out your back. They are extremely efficient. Like I said, they're quiet. So there's a lot of very compelling. You don't lose your window. There's no security. There's security issues. So there's a lot of reasons. I'll take one more question, and I'm going to try to keep moving through.
For the multi-zone, you're required to have piping going around outside the house?
Yeah, the question is, if you've got a multi-zone heat pump, do you have to have all these pipes kind of running all outside around the house? It's one way of getting there. You got to find, however you can, connect the pipes to the indoor units. You can run through the basement. I've heard of running through attics. I've heard of building chases. I've heard of popping up into soffits, overhang eaves. But it's not uncommon because it's relatively inexpensive and relatively easy to just run around the outside of the house. But it's an aesthetic concern for a lot of folks. So I'm going to move on just because we do have still a bunch of material to cover, and we'll have time for questions at the end. So what's a good building? These things are incredible. I want to start off by saying, as I mentioned earlier, these are very, very flexible pieces of equipment. You can make them work in pretty much any situation. I've seen all kinds of crazy ways that these have been installed that have worked out very well. That said, there are better and worse applications. A well air-sealed and insulated home really is important, especially if you're going to have like one or two heads, because the further you get away from that heat source, the colder it's going to be. So not only are you using less electricity, but you're going to have a wide variation of heat, right? Right around the unit it might be 70, 72 degrees, nice and comfortable, but the further you get away, your bedrooms could be in the 50 degrees or even colder if you're very poorly insulated home. So this becomes elevated, this air-sealed and insulated piece. So we always recommend, if you have not evaluated your home, we have resources to help you do that. Give us a call. Open floor plans or keeping your doors open. If you've got a real broken up home or closed doors, heat doesn't do very well around corners and through doors as it does in nice big open floor plans. Doesn't mean it can't work, it's just not ideal. Multi-story tend to be a little bit easier to heat with these than big sprawling ranches. So if you have a 8,000 square foot ranch that just keeps on going, you're going to need a lot of heat pumps to sort of pick that up. Versus, a home that's stacked, you're going to tend to have, heat likes to go up, right? Easier than it goes sideways. Existing multi-zonal heat, so if you have a single zone furnace type of thing, one thermostat in your house, it gets tricky from a control standpoint as to who's doing what job. Is the heat pump doing it? Is the furnace doing it? So those are a little trickier. They can be done, but it's trickier. As I mentioned earlier, you want to have a functional backup system. If you do currently have really expensive fuel, it's all that much more compelling from a financial perspective. You know, if you're heating your house with wood, it's gonna be. I'm not going to sell you on the fact you're going to save a lot of money if you put a heat pump in. Okay, you won't have to split wood or haul wood. There's a lot of other bonuses, but. And if you have renewable access to renewables, whether it's community solar or solar on your roof or micro wind or whatever, again, really, really, these are incredibly good pairings. So talk to some of these folks over here that do solar. So what makes a good installation? That is not a good installation. So we like to see these up off the ground. You know, this is what happens when they sit on the ground. They freeze right up, which is not good. And that's only with what, like 2 or 3 inches of snow on the ground, which we obviously had a little bit more than that this winter. I wouldn't install them right under an eave without a cover because I've seen them get pelted by ice falling on them, or dripping can cause lots of problems. It can start to get inside the case and freeze up. That can be a real problem. The indoor unit, I like to see the indoor piece, right? The thing right under the sign there. I like to see that in a place where you spend a lot of your time hanging out, living, kitchen, dining areas, those kinds of areas that have a lot of access to volume of the space. It's also really important. The refrigerant line, that's the thing that connects the indoor and outdoor unit. Like I said, you got to drill a hole, right? You got to connect these things. Inside, outside, you got to drill a hole. And so if the person who comes to do that, and these guys would definitely not do this, but some folks might just drill a hole, run the pipes through, and leave. Well, you got to seal that hole up, right? Otherwise, you have a big hole in your wall. And you laugh, but I've seen it done. So that line set, right, the refrigerant line, you need to make sure that's protected. So again, if you work with any really good installer, they're gonna recommend some kind of line hide material that protects it from getting banged and the sun beating on it. It's not pretty to look at anyway. So it sort of looks like a gutter flips inside out. You've probably might have seen these. Think a gutter flipped upside down and kind of caps over it on the outside of the house. And then, as I mentioned earlier, you do have to think about how this is gonna work, or at least work with your installer to think about how this is going to work in connection with that existing heating system. You don't want dueling heating systems. You want them to be working in concert or in connection with each other and not against each other. So some additional considerations. So they make noise. The outdoor unit has a compressor in it. They're very quiet. The manufacturer, so I'd like to use the term whisper quiet, but they do make noise. If you're somebody who's sensitive to noise, you should probably go over and listen to what one of these things sounds like, or find someone that has one installed and listen to it. The indoor unit makes even less noise. One second. It makes even less noise. It's just got a fan in it, and it's a very, very quiet fan, but it does make some noise. Comment here?
Below 10 degrees, it sounds like an aircraft revving up to take off.
Yeah. And I've heard this, you know, this is not a universal statement, but I've heard this before. And that can be for a lot of different reasons. It could have something to do with the installation itself. There could be some issues with the equipment. You know, whether it's hung on the home, a lot of folks like to do it. That's what I did on my home. It's easy. It gets it up off the ground, but some folks prefer a stand outside, but one way or another, you do got to get it up off the ground. I'm sorry. The concern is, she said that when it gets below 10 degrees, the unit sounds like, the outdoor unit sounds like an aircraft carrier. You know, aircraft revving for takeoff. Yeah. So loud, I think.
And the house vibrates.
One more quick.
Elaborate on it a little bit.
Yeah.
It's what that inverter compressor, when it's ramping up and down, especially when it's colder, it's really ramping up a lot. And if it's mounted to the wall, there is a little bit of vibration. You can go outside and it won't sound that loud, but you won't hear it on the wall. So if you have it wall mounted, we're doing a lot of rubber mounts behind the mount to help that.
Yeah.
Or even though with that picture you showed, the slim, off the ground.
Yep. So again, if you're sensitive to this kind of thing, I'm trying to give you guys some things to think about if and when you decide to go down this road. You'll have the questions ready. You won't be surprised by this once it's already in, right? So they're not invisible, right? So like some people are really surprised somehow when these things go in. It's like, oh, I got this big thing on my wall now. I hate it. It's horribly ugly. Big plastic thing, you know. So that's what they look like, or there's other versions, but they all kind of look like that. So you have to be ready. There are new versions. I think these guys are featuring here some of they now have floor-mounted ones. You could do ceiling recess. There's a lot of options, but just look into that. And there's also the outside of the house, right? It's going to go in the flower bed or somewhere. You might be thinking in your head, where would I put it in my house? So you do see them. So it's a concern.
Are they all white?
They tend to be white. I've seen they have them in other countries. They've red. I've actually seen. You'd be amazed that the largest complaint I understand from a lot of manufacturers is not about efficiency. It's not about any of these things. Not about noise even. It's about that they look ugly. So we are, for whether we want to admit it or not, we as a people are somewhat hung up on aesthetics. So. I only point it out just to keep it in mind.
Can they be painted?
Some can. I wouldn't. There's louvers and all sorts of things, but I have heard some manufacturers say that you can paint it. I'd be very, very careful with that. So I would talk to the manufacturer before or your installer before painting. One more comment, and I'm going to move on.
Given that heat rises, how is it that they are up and mounted so high?
That's a great question. The question was, if heat rises, then why are these things always often so high up on the wall? I don't really know the answer to that, but an installer would do better, but what I would say is that it's likely a result of the historical use of these have been really for air conditioning. And from an air conditioning perspective, that does make more sense. They do a lot. They have really good what they call air throw. You do want them up out of the way, too. I mean, that's another big piece of it, is that you don't want it in a place where you're going to bang into it. I mean, there's some delicate stuff going on there. If you've got it up and out of the way, you're not as likely to bang a chair into it and all that. I mean, guaranteed you will hit it. If you left that down, you will hit it with a vacuum. You will hit it with your elbow, or the dog will get it, cat or somebody will get into it. So, as I said earlier, they do decrease in output as it gets colder. That is the law of air source. Maybe I shouldn't just call it a law because I've already been blown away on by so many things. But in the immediate future, even the really good ones are going to put out less heat as it gets colder. And the efficiency is going to go down as it gets colder. So you have to know that going in. You have to pay attention to whatever you've got in your electric panel. If your panel is just bursting, you've got everything double tapped and all that, you may need additional installation costs to do some work. Upgrading your electrical service, putting in a sub panel. Doesn't take a ton, but you do need you need 2 empty slots for double breaker. And one thing I really do want to point out, because I've had a lot of people say, make sure you say this, is that some of the equipment has a limit on how low you can set the temperature on the remote, right? So a lot of folks are thinking about this for the bonus room, and they're not going to use it very much. I'm going to try to keep it really cool. And some of the units you can't turn down below 59 degrees. So ask the installer, look into that, okay, before you select a piece of equipment. Not all are the same, and some make additional accessories, wall-mounted thermostats and such that enable you to put lower temperatures. So just gives you one other thing to think about and ask.
So you're telling me it has to be on?
No, you can turn them off. You can turn them off. But they do operate most efficiently when they're humming along, just maintaining temperature, both heating and cooling. It's not like your conventional heating system. Let them run. Don't use setbacks like you do normally, right? You're surprised you heard someone from Efficiency Vermont telling you don't use setbacks. But for this equipment, you don't want to use setbacks like you would with a conventional heating system. You want to let them sort of hum along, find their happy place and hum along.
So actually, if you have a Nest thermostat, they say you can do the setback without the
efficient about doing it?
Well, Neston, most of this equipment is not compliant with, does not work with Nest. So something to keep in mind.
So you're really saying, don't use a heat pump if you're looking for a backup heating system?
Question was, am I saying don't use a heat pump if you're looking for a backup
Wood
heat?
heat and no other?
I'm not saying that. It depends on your situation, and I don't want to get too down a rabbit hole. You just have to think about how you're going to use it, whether or not this is a good fit for you. So I want to talk a little bit about our program, just so you know what's available for you. So we have what we call an upstream program. So this is not what you might be used to for any programs if you've worked with Efficiency Vermont in the past. So the way this works now, we are providing a $300 discount at the point of purchase, but that discount is being given to the installer when they come in to buy it. So you just need to make sure that when you're getting your quote from your installer, that $300 discount is being handed on to you, okay? So there's no forms, there's nothing to, and you can get multiple quotes if you feel that if you're being taken advantage of. I highly recommend that. But the discount, the money that we're putting into this, you're not gonna get a check at the end, okay? It's a simplified, streamlined process that we're only supporting certain equipment, and that equipment is being reduced in cost at the point of purchase at the wholesaler. So, sure.
Is there any similar program in New Hampshire?
I do not know. I was asked that once already. Yes?
Yes, but it's through the utilities.
Okay. So you'll have to talk to your electric or gas utility? Yes?
Back on your last slide,
Oh.
in your projections for savings, are you considering the fact that your load is going to increase 10 or 15% because you've got rid of your night setback?
Not necessarily true. And it has to do with the fact that the question is, if you're not getting rid of a setback, if you're getting rid of a setback, is there an increase in your load? The actual, I know you're probably skeptical about this, but heat pumps there's a huge variation in how efficient a heat pump can operate, a single piece of equipment. It's not a static efficiency, it's very variable. And if the heat pump is working harder to bring you up to temperature, it's operating at its least efficient. So if it's maintaining temperature, that's its sweet spot. It's operating very efficient. So even if it's running for more time, it's running at a much more efficient.
I understand that, but the question was, are you building in the increase in use? Or are you just taking the amount of oil and converting it to some certain COP?
All of that has been taken into the equations.
So you increase the oil and then convert it based on 2.5 or whatever the COP is?
If I understand your question right, I think the answer is yes, but I don't want to back myself into agreeing to something that I'm not entirely sure that I understand. So I'm going to move on here. So in terms of which equipment is eligible, right now we're supporting 3 different manufacturers that you can see here. They all meet the requirements that you see above here. Some of these things should look familiar to you now. This would have looked like a foreign language probably before tonight, but these are the requirements. You can look at this later. Fortunately, I know this is way too small to copy down, but if you're looking for the actual eligible products, you can either work with your installer, who will help you, or you can go onto our website and take a look. These wholesalers are all working with us as partners now, so these are pretty much all of the major wholesalers in the state of Vermont. I also do want to point out, we have a new collaboration with Green Mountain Power. Is this Green Mountain Power territory down here?
Yeah.
Yes. So for those of you who do live in Green Mountain Power territory, you also have the opportunity to lease this equipment or rent this equipment. And so the rentals are somewhere in the, say, $40 to $60 a month. They don't charge anything to install it, no upfront costs. They'll come and put the equipment in. You do have to pay for the electricity though. And there's no maintenance fees, no upfront costs, and because of the collaboration with Efficiency Vermont, the first 6 months are on us. So. One comment?
Have those numbers changed in the last year or so, the cost? No? Okay.
No. See questions all over here, but
I'm thinking about getting heat pump, hot water.
Heat pump, hot water heater. You mentioned passing it was $1,000 and $500, and I saw bloggers up there, and I was dealing with them, and they told me that it was $1,500 and $500. Did you think that might not be a question for right here, right now? But I just
yeah, I'm gonna have to pass on that one in terms of pricing. It depends on the equipment and the size of the equipment and all that. Yeah. Shop around.
Okay.
I'm sorry, I'm gonna have to hold questions just for a minute. I'm almost done and then I'll take questions, but I wanna make sure, Bob, I don't know if I can get a time check. How am I doing?
It's almost 7 months.
Okay, so I really gotta blow through. I got just a couple more slides here. I apologize. So we do have, I'm actually gonna really skip through a lot of this stuff. There's a lot of opportunity for financing as well. So if you're wondering where the money's gonna come from, it seems like a great idea, but you don't have $4,000 or $7,000 sitting in your bank account. There are financing opportunities out there. I do have a couple of sheets left here for what's called the Heat Saver loan at the top. Really, really great low interest, streamlined loan process. Yeah, so for homeowners, as I mentioned, Heat Saver loan this is a PACE area. There's a bunch of PACE towns around here too. So if you don't know what PACE is, Bob will talk to you about that later. He'll probably be able to help you out in some way. Is it fair to offer that service? Okay. For businesses, I don't know if anybody's here representing for their business, but there's all sorts of, we have business energy loans. Call us, we will help you with financing if that's something that you're interested in. Of course, we offer all sorts of other things, such as home weatherization, LEDs, all this stuff works together. So that's it. I kind of went into high gear at the end there. I don't know if we have a few minutes for questions now, so.
Maybe 5 or 10.
Okay, so I'm happy to just try to get around the room a little bit. Question over here?
Yes, I have a question about these new refrigerants. Are they CFC-free, ozone-friendly?
Yep, so the question is about the refrigerants. This is that material that's inside the system. It's not something that gets used up. If done properly, it should stay in there. The question is, are these CFC-free refrigerants? Refrigerants historically have had very high CFCs, and those are ozone depleters. So all of the new refrigerants in here have what's called a zero ODP or zero ozone depletion potential. So they're completely benign from an ozone perspective. However, I do want to point out the refrigerant itself is actually a greenhouse gas, a pretty nasty greenhouse gas. They're about 2,000 times by weight, 2,000 times worse than carbon dioxide. However, we're talking about still pretty small amounts, and because when these things are operating, they're actually offsetting fossil fuel use and carbon dioxide, the net benefit is out of the ballpark. So
This is relatively new equipment, but is there any idea of the expected life?
yeah, so the question is about expected life. Heat pumps have been around for 50 years. So the technology is different than your refrigerator, but not as different as you might think. The number I keep hearing is 15 years. I've heard some people say 20. Frankly, I think it depends a lot on how you maintain it. But I think somewhere in that ballpark, I know some of the better manufacturers are providing 7 to 10-year warranties, so that starts to give you a sense of what they're thinking. Maybe
Jake, we've got a viewer online that asks a question related to that about the replacement costs of components.
Yeah.
Is it something that it's going to be expensive to fix down the road?
Yeah, the question is about the cost of essentially maintenance costs and component costs. Most of the standard maintenance is really almost non-existent. It's more or less just cleaning the outside coil once every year, every other year, keeping the there's an indoor filter on the unit. It's kind of like a laundry, like a dryer filter that you clean yourself. Other than that, if something goes wrong, it really kind of depends. If it's the compressor, that can get pretty expensive pretty quick if it's not covered under warranty. But it's gonna really depend on what the component is. So, next question.
You didn't want to talk about the ground installation systems, but the high dollar figure, is a lot of that the actual excavation and drilling and all that stuff?
The
Or
question is why is ground source so expensive? Yeah, the equipment isn't really that different, really, when it comes down to it. It's the earth link. It's the piece where you gotta get a big, massive, deep well and all the pumps and all of that kind of thing, or you have to excavate, lay all this pipe. So that's where a lot of the expense is. Couple more questions.
Two-part question. One, is there a condensation pump? I had a heat pump primarily for cooling when I
Yep.
went to Mississippi, August stream.
Yep.
And condensation was an issue.
Yeah, the question is, do they have a condensate pump? The answer is no, for the most part. The coil that gets cold is the thing that hangs on the wall, and that actually usually is on an exterior wall. And there's a drain pipe that just runs right straight out in with the rest of the line material.
Second part of the question, are any of these manufactured in the U.S.?
The question is, are they manufactured in the U.S.? The three manufacturers that we all have featured, Daikin, Fujitsu, and Mitsubishi, you can probably tell just by the names, they're not American names. They're all Japanese companies. There's Chinese manufacturers, Korean manufacturers. Carrier, which is probably the largest American manufacturer, is a little bit late to the game, but they've got big plans. We'll see what happens. They do make products that they call cold climate. They haven't met and made our list yet, but stay tuned. I think maybe one more question. Let's see, someone I haven't heard of. Here? Yeah.
So the multi-zone, this might be an installer question, but the multi-zone units, can you start up with sort of 2 zones and then add on over time, or does the actual source unit have to get larger in order to accommodate?
I can let people get into detail on that. The question is, if you buy a multi-zone system, can you sort of add on to it over time? Maybe I should just defer. Is there somebody who wants to really take that?
You could do that. You could buy a 42,005-zone outdoor unit, connect 2 indoors, and later add to that. But you really want to plan for it. You can't say, oh, I only want a 2-unit outdoor and add to that. You got to get that primary outdoor first.
And I will say that having a balance, there are constraints in terms of how off balance the indoor units can be to the outdoor. There's a compromise in efficiency there, so trying to get that balanced is kind of a key piece, but it can be done, as these guys mentioned. So, what's next?
Well, we may have time for a couple more questions, but I want to do a couple things first. First of all, I want to thank Jake. That was great. So there's a few things. Jake brought an evaluation form, and we'd love to have as many of you who are willing to fill it out. I'm just going to start it here, and you can pass them back. If you don't have a pen, there are pens on the registration table, and you can take it out with you at the end and fill it out at the end. Thank you.
We do read these, and I have made many changes to this presentation. This is the 4th of these, and I have changed them each time as a result of these. So please do write them.
A couple of other things. I forgot to mention that we're going to try to recycle all these cups or reuse all the cups. So if you had drinking cups, just make sure you don't pull them out, put them back on the table back there, and we will wash them afterwards. If you didn't get it, at the registration table when you came in, there was a yellow piece of paper. And what that is we did a polling of all of the heat pump installers in the Upper Valley area, and this lists the heat pump installers, their contact information, the type of equipment they put in, how many they've put in, that kind of thing. So you can make sure you take that with you. And actually, Jake's and Serge's contact info is also on there. Related to that, we're going to be also posting a link to the video of this presentation, as well as we'll be posting, if it's okay with you, the Jake's slides from the presentation. So if you're not on Serge's list and you want to be, to get that link when we send it out, our contact info is on this yellow flyer. Just send me an email saying you want to be added to our list. We don't sell or share the list. Evaluation. Okay, so we wanted to do a couple of other things. Is there anybody here who's lived with a heat pump that wants to just stand up and say a few words about it? Anybody? Yes, no? Yes, back. And you're welcome to come up here and use this. It'll be easier for people to hear, but you don't have to if you don't want to. And if the installers want to come up front, I'm going to have you introduce yourselves in just a minute.
So, hi everybody. Oh, I'm being blinded by the light from this thing over here. I'm David Cahill. I live in Thetford. We just built a house in Thetford, and it's about a 2,200 square foot house, and it is exclusively heated by heat pumps. And we have a wood stove that we use for backup heat. And I can tell you the wood pile didn't really change in size at all this past winter. So the great thing about the heat pumps is that they were so effective, even down at temperatures below zero, that we just never really felt the need to use the wood stove, and we had the luxury of being lazy and not using the wood stove. And the way we did it was we just had a separate heat pump head on each floor of the house. And actually, if you want a better explanation of how it actually worked, our installers here, Brent Mellon with Building Energy, we had the benefit of having him live right down the road, so that was awfully nice.
What does your electricity cost?
So the question is, what does our electricity cost? We don't have a really good year-round baseline because we moved in for the winter months into our new house, and we also have a heat pump hot water heater. I can tell you right now our average bill, looking from November through the present, is in the $200 and something range per month.
How many people is that?
How many people are in the house?
Yeah.
Me and my wife, so 2 of us.
What's the square footage?
2,200?
One unit on each floor?
Yes.
But even in this really cold winter, I thought you couldn't use it. I thought you couldn't use 100% heat pumps.
Oh, well, so that also is part of the design of the house. I mean, that the house was designed to be very tight. I mean, the walls are 11 inches thick. So that's a variable you have to take into account. I imagine putting a heat pump into a house that was built in 1960 to the specifications that were then commonplace in 1960 is to be different. But our house is tight enough that, if it got down to -20 for a few hours overnight and the heat pump shut down, you wouldn't really notice it in the house.
Wow.
Okay, thank you very much.
Thank you. Anybody else wants to say anything about their heat pump experiences? If not.
I'm Doug McElroy, and I live in Hanover. My story is cautionary. I live in a house that's extremely well insulated, R40 in the walls, R50 in the attic. It has had a heat pump installed in 1982. By the time we bought the house in 1997, the ground, it appears what's happening is the ground resource is slowly depleting. And the 47-degree ground temperature gradually came down to meet the 45-degree cutoff temperature of the heat pump. The heat pump got to a point where it would come on 10 minutes and shut itself off. So we finally removed it. By now, perhaps the ground is back up to 47 again. Why am I here tonight? Because I'm interested in heat pump in the air source heat pumps, which may work for my outbuildings.
It's real brief one. We have a heat pump water heater in our basement, and there's an added benefit. It's a dehumidifier. We've had much less mold in the basement since we've been in, so it's a significant thing.
Great. I think we're going to go now on to the installers, and I'd ask all the installers to have one representative come up and take a minute to introduce yourselves and your businesses, and then folks will be able to talk with these contractors afterwards. A question for Jake. Yes, Jake will certainly be around after the installers talk. So.
My name is Brent Mellon. I work with Building Energy. I live in Thetford, and we do energy audits, insulation, air sealing, solar, and we do heat pumps as well. And so what we want to do is we take a whole building approach, a comprehensive approach to your building, and come in and do an energy audit. We want to see where can we reduce the heating load, where can we make your house more comfortable, what kind of leaks can we seal up, where can we add insulation, and then what can we do?
Speak up, please.
Quiet in here.
Sorry. Is that better?
Yes.
Okay. Should I start over?
Yeah, you're fine.
My name is Brent Mellon. I'm with Building Energy. I live in Thetford. We take a whole building approach to energy use. We do energy audits, insulation, air sealing. We do solar, and we do heat pumps. And so what we want to do is come into your building and find out how can we make the building more comfortable and more efficient by air sealing and adding insulation, paying attention to ventilation. And then can we add a heat pump to reduce your energy use, reduce your reliance on fossil fuels, and then possibly add solar to offset that initial electric use. Thank you for coming tonight.
Gotta keep it going. How you doing? First off, Jake, that is a tremendous job. I've been in this business for close to 25 years, and he was spot on with his mechanics, the whole 9 yards. Really well done. I was quite impressed. So if you need a job, you know, come. I'm with ARC Mechanical. My name is Jody Perkins. We're a locally owned company. We've been in business since 1947. Originally known as Allen Refrigeration Company, and that's what ARC stands for. Heat pump technology, as Jake had mentioned, has changed tremendously over the 5 to 7 years, last 5 to 7 years. We've been installing mini splits, ductlesses for 25, 30 years, so this is not new to us, not new technology. We get that question a lot, well, this is new stuff coming out. Well, it really isn't. We've been doing it a long, long time. We have highly educated people doing this, local salespeople. We send people to Boston for education all the time. We do commercial, residential. We work with many contractors, can really look at the building. Highly qualified technicians. So, you know, we have an office right here in West Lebanon where Paul works out of. Glad to come out anytime to visit your homes. So thanks for coming out. Really well done. Thank you.
Hey everyone, my name is JT Lukens. I work for Suncommon. We're a solar company. You may have seen our cars cruising around. We also do heat pumps. We do residential solar systems, community solar systems, and we offer heat pumps to help obviously get rid of fossil fuels. As a company, we believe that everybody has the right to a healthy environment and a safer planet, and clean energy is kind of the first place where that can start. Our mission is to break down the barriers that have kept people from going solar, namely the affordability. And so we really make it easy and affordable for all Vermonters to go solar. We offer financing. It's usually a standard 12-year low-interest loan. So you can basically replace your electricity bill with a payment for the loan, for the panels rather. And then once it's paid off, free power coming in, obviously. But we've done a lot of heat pumps. In 3 years, we've helped 1,500 Vermont homes go solar. So if you're a renter, if you're in the shade, that's not an excuse anymore. You can join a community solar array. If you're interested at all, stop by my table. We do free estimates. And yeah.
I think we'll take questions after. Can we get all the...
Sorry.
Hi, my name's Doc Bagley. I'm with Catamount Solar. We're a member-owned workers co-op out of Randolph, Vermont. We're primarily a solar electric installer. We've worked with a number of contractors here. On the heat pump side, we have decided to go certified on installation for heat pumps. And our main focus really is to couple that with our solar installations. So we still hope to work with some of the contractors here that are solely working with heating and cooling, but also want to be available to people that are doing solar installations and want to have one contractor to work with. So we'd love to talk to you right over there. Thanks.
Okay, that's it. Yes, ma'am.
I just want to know how many of you work in New Hampshire as well as Vermont?
How many of the installers work in New Hampshire as well as Vermont?
I live in New Hampshire.
Ah,
1, 2.
okay.
Okay, so all 3 out of 4. Suncommon doesn't yet, but the other 3 do. Any other general questions? Yeah.
In reference to the solar issue, some states are starting, or I should say power companies, with the blessing of the states, are levying now a fee on your solar installation. To give you an example, SRP, which operates in the Phoenix, greater Phoenix area, just levied a $50 a month fee for people who put solar on their homes. There's another regulated electric company in the Phoenix area. They got approval last year. They wanted $25, but the electric board only allowed them $5 fee. Is that happening, or is there any undercurrents here in New England of that happening?
I don't believe anybody's working on that kind of thing. I've heard about that, but I haven't heard anything about that neither.
It's the other way around. There's actually, because of our net metering laws, you actually get paid more for the power you produce than for the power you buy.
In Vermont. That's in Vermont, yes.
That's not my question.
But no fees on top of that.
No, that's the question.
Right.
Florida also.
Yeah, there are a couple of states who are trying to do that. Yep. I think we're going to call it an end of this. If we could have folks help put the chairs away, that would be really helpful. And then